In today's video, I'm going to share with you the chain rule. The chain rule, especially the lebniz notation. That's what we're going to cover just in a brief way, how we could find actually the derivative of composite functions. Actually, the chain rule tries to give you hints, gives you ideas of how you could find the derivative of a composite function. Okay, a function that's inside another function is called a composite function. So let's go and let's get started. And if we have, let's say we have a function which is like this: y is equals to 6u minus 9. Okay, let's say we have such a function, 6u minus 9, and this u and the u here and the u is equal to a half x power 4. Okay, half x power 4. So this is a function here inside this function of y, a function of u inside a function of y. Okay, so the how to find its derivative is what we're gonna learn here using a method called lebniz notation. Okay, lebniz method. So the way to do it will be like this. Now, since y is a function of u, so we can call this f of u. F of u is now equal to 6u minus 9, right? Because y is a function of u. Okay, now while this one now is a function of x, so we can call it g of x is equal to a half x power 4, right? That is what we can call it. Now, when we want to find the derivative, let's say we want to find the derivative of f of u. So, to find the derivative of f of u, we will just use the basic rules that we have learned. So, this is going to give us 6u minus 9 is just going to give us 6. While the derivative here of g of x is going to give us what? We are going to bring this 4 down here. It's going to give us 2x power 3. Okay, so that is what we have. Now we want to find the derivative for the general function. So the general function, how we are going to find it is we're going to in order to find the derivative of the general function, it's going to be like this: finding f prime of g prime of x. Okay, so this is where we want to get the derivative of the overall function. So that is going to be 6. We multiply it with the derivative of f of u multiplied with the derivative of g of x. So that is going to be 6 times 2x cubic. Okay, let me just use here a dot. So we will multiply them. So 6 times 2, that is going to give us 12x cubic. So the derivative for that function is 6u minus, the derivative of the function which is of y is equals to 6u minus 9, where u is a half x power 4 is now this that you can see, which is 12x cubed. Okay, now let's take another example. Okay, let's take another example. Let's say we have this function which is y is equals to 2u cubic, where u is equals to 8x minus 1. Okay, now we need to find the derivative of each one. So now that y is a function of u, we can call it f of u, just to simplify things. So f of u is equal to 2u cubic, while here u is a function of x, so g of x is equals to 8 x minus 1. Now the second thing is just finding the derivative of u, finding the derivative of, of f of u. So that gives us 6u squared, just applying the power rule that we have learned in the videos earlier. Okay, so here, while the derivative here of g of x is gonna be, is gonna be basically 8, right? It's just gonna be 8. Okay, now what we want to do is we want to find the general derivative of the function, the overall derivative of the function. So it's gonna be like this. So in order to find it, we will just say, let's find f prime of g prime of x, f prime of g prime of x. So this is what we, so we're going to multiply the derivative of f of u times the derivative of g, the derivative of f of u times the derivative of g of x. So that's going to give us 6u squared times 8. So we can substitute for u, so it's going to be 6. So instead of u, we can write 8x minus 1, and then we square it, then we multiply with 8. So this just gives us 48 8x minus 1 squared. So the overall derivative just gives us the overall derivative for the function, for that composite function, just give us this, which is 48 8x minus 1 squared. Now, so that we can summarize this, let me just give you what the notation, the Leibniz notation states, so that you can understand how you can use it in different questions. So the Leibniz notation states that, let me write it here. So what this guy want to say is, if you have, so he's saying if f of u is equals to y, or f of y is equals to f of u. Let me just try it the other way around. If y is equals to f of u and u is equals to g of x, if you have this, he's telling you, then the derivative of that function, of the whole function, dy all over dx, if you want to find the derivative of the whole function, then you have to first find the derivative of y with respect to u, that's dy or du, and then you multiply it with du, the derivative of u with respect to x. So that is what actually the Leibniz notation states. If you want to find the general derivative of a composite function, so first you have to find the derivative of y with respect to u, and then find the derivative of u with respect to x. Okay. Having said that, I hope you have understood how you can use the Leibniz notation to find derivatives of a composite function. But still, we are in the chain rule. In the next video, I'm going to share with you how you could use the outside-inside rule to find derivatives of a composite function again. Okay. See you in the next video. Meanwhile, if you didn't subscribe to the channel, you may subscribe to it. Thank you, everybody.